about combining like terms. So this is another form of simplifying, but we're not going to be given values for these variables. We just want to combine them as they are. So there's a lot of vocab embedded in this that we need to be familiar with. A constant, this is a constant, this -9 at the end of this expression is a fixed value with no variable. That has an x, that has a y, there is no variable on our constants. A variable is a letter that stands for an unknown numerical value. The coefficient is always attached to that variable, so 4x, 4 is the coefficient, 2y, that plus 2 or positive 2, that is our coefficient. It's a number being multiplied by the variable. We have 3 terms in this expression. That's one term, that's a second term, that's a third term. So when I say combining like terms, I'm looking for what of these are like terms, what is in common between these terms. Those are the terms that I'm allowed to combine. And the way we combine them is by adding and subtracting. So like terms are always going to have the same variables, and they're raised to the same variable factor. So they have the same exponent. That's what I'm looking for. Same variables and same exponent. So we're just trying to identify if these are like terms. 4x, 8x, they have different coefficients, but that's not what I'm looking for. They each have an x, and there is no exponent on that. Those are like terms. -7y, just the number 9. Those are not like terms. One has a variable, one doesn't. I can't put those together. The numbers 2 and 11, those are both constants. I can add 2 and 11 together. Those are definitely like terms. 12x, 12y, same coefficient, but that's not what I'm looking at. That's got a y, that has an x, that has a y. Nope, those are not like terms. These ones look complicated, but we're really just trying to match x squared times y, x squared times y. Those have the exact same variables with the same exponents. Those are like terms. It doesn't matter about the coefficient. I'm just looking at the variable parts. So those are like terms. If they are like terms, that means we're allowed to combine them, which means adding and subtracting. So here I'm going to just identify which like terms I have. I have 4x and a plus 2x. I'm going to rearrange this so I group my like terms. 4x plus 2x. I would like for you to write this with me. Regroup this, rearrange this so that your like terms are put together. We have 2 constants here, 10 and 1. We're going to rewrite those with the sign that's in front of the number. That is a plus 10, that's a plus 1. That sign is attached to that number. It comes down when we rewrite that. Now I can put these together. I'm adding my like terms together, 4x plus 2x. I have 4 x's plus 2 x's, now I have 6 x's. 10 plus 1 is 11. So rewrite your expression so that all of your like terms are together with the sign that's in front of that number. And then combine them. 7x minus 9x, that is -2x. -12 plus 4, this part equals -8. When I write my final expression, I'm putting these two together with the sign that's in front of them. The order actually doesn't matter. -2x minus 8 or -8 minus 2x, these are identical. The sign that's in front of the number did not change. That's really what I'm looking at. That's a -2, still -2. That's a -8, still a -8. You might be thinking that's subtracting 8, but those are the exact same thing. All right, here I'm combining my 2x terms, -12x plus 6x, my 2y terms, 7y minus 3y, and the z doesn't have anything to partner up with, so that's just going to be rewritten in my answer. Nothing's going to change that, so I know I'm rewriting that in my answer. Here I'm going to combine these. I get -6x. I combine these, I get 4y. Again, the order doesn't matter. Traditionally, you'll see these in alphabetical order, so I'd see -6x first. There's a positive 4y, so you write plus 4y. And that's our expression. That is as simple as that gets, because each of these has a different variable. All right. This one looks more complicated, but it's the same thing. You're just trying to match 4a, 13a, 2ab squared minus 3ab squared. And these b squareds are also like terms, same variable, same exponent. So now I'm going to put these together. I'm actually not going to rewrite this one. I'm just going to add them together as they are. 4a plus 13a, that is 17a. 2ab squared minus 3ab squared. 2 minus 3 is negative 1. Now, you could write this as negative 1ab squared, but usually, when it's a coefficient of 1, you don't actually rewrite that 1. You'll just write it as minus ab squared. If you happen to write it like this, I would never mark that wrong, but usually in multiple choice questions, you'll see it just written like this. And now the last one's 4b squared minus 7b squared, 4b squared minus 7b squared. That is negative 3b squared. Right, last one on the front where we're just combining, we have 4y plus 7y minus 1y. So you can see we could also do this with 3 terms, doesn't really matter. 4y plus 7y, we're still just combining using the sign that's in front. So it's 4 plus 7 minus 1, that is 10y. And then our other 2 like terms, negative 5 minus 9, that's negative 14, so we write it as minus 14 in our answer. Again, the order does not matter, as long as the sign doesn't change. This is a positive. You don't write a positive there, you don't write a plus sign, but that shows up as addition when you write it at the back end. All right, sometimes we're also going to be given these models where we just have to basically describe what we see and combine like terms if we need to. So here I say I have an x, these are labeled as x's, I have another x, I have another x, so I have 3 x's. It's really just counting up how many x's I have. Each of these is a negative 1, so I have 4 negative 1s, that's negative 4. Gets a little bit more complicated, but not really much. I'm going to label everything that I see there. I see negative 1x plus 2x. I see 4 and negative 5. And then I see 3y's and negative 4y's. So I'm going to combine each of those. You get 1x, you get negative 1 from that constant, and we get negative 1y. Again, when we have a 1 as a coefficient, we're not really going to write that 1. You just leave it as just x there. Same thing here, negative 1 just shows up as a minus sign, and then minus 1 for the constant at the end. Same thing, these blocks are each marked as x squared, so I can combine each of those, really just count them. That's 3x squareds plus 1x. I'm going to rewrite that though. You're right, it's 1x, but we just write that as x. And then 1, 2, 3, 4, 5, 6, 7. Negative 7 is my constant there. Last problem, Mr. Nickus, I want to find the perimeter of that shape below. The perimeter is adding up the sides of a shape. So when I'm talking about perimeter here, I'm just talking about combining like terms. I'm adding all of these together. So I'm going to combine like terms. 4x plus 5x plus 2x, that's 11x. And then 2 plus 12, that's 14, plus 6, that's 20, plus 8, that is 28. All right, try the U-try on your own, and get it checked when you're done.